Right, we'll be doing some example since I don't think you have the time to do the example. Right, essentially, a review what we have gone through. A point outside a uniform sphere, the mass of the sphere may be considered to be at a point mass at center. Right? If it's a uniform sphere, we consider the mass to be concentrated at the center. So any body or any object around it has a field. Example, the Earth, around the Earth, there's a field. Around the Moon, there's a field. So how do we find the gravitational field strength? We take a mass, called a test mass, find the force on the test mass, and then take this ratio, force per unit mass, find the gravitational field. Then we study Newton's law of gravitation, forces between point masses. Right? That's the force.
Yeah, teacher.
Yep. Bit louder.
I don't have this one.
Can't hear. Let me turn on a bit louder. Say a bit louder.
Uh, the you say you prefer classes after 8:30, is it?
Then I don't have to shift my gear around. Lor.
Or is it more convenient for you?
It's okay with me if you feel that if you prefer this time, you can carry on, but it is more convenient for me, of course. But if you prefer this time, then we can carry on. Lor.
Actually, I'm also okay on. For like, I think Tuesday or Thursday, 8 9 o'clock. Can 9 o'clock.
9 o'clock can. Tuesday, no problem.
Thursday?
Thursday, sometime may have problem lah.
Oh, okay, I see.
Sometime may not have lah.
That one maybe I will ask for special request lah. But for
Anyway,
now,
you let me know lah. You think about it and
fixed
let
time
me
is
know lah.
fine.
Or next week lah.
Okay.
Okay, so the force between the 2 point mass is given by this formula. Right? Called Newton's law of gravitation. How do we know it's a point mass? As long as that distance, the distance between the center to center, is greater than the size of the masses. Usually we tend to think of it diameter, but size is better because it may not be spherical. And after that, we study motion of satellite. Essentially, you need to memorize centripetal force equals gravitational force. Then from
Yo,
there, we get this formula.
sure.
Yeah.
I don't have this file.
I sent you much earlier already.
Um,
Okay lah, you don't have, I'll send you again. I'll send you again after the like lesson. So from that, we derive this formula, and then by replacing V with that 2 pi r over t, we can show t
yo,
squared. Yeah,
is it together with the previous chapter
with circular motion.
or with circular motion one, right? Oh,
Ah,
okay, yeah, I have it. I have
because
it.
these two is under mechanic.
Oh, okay.
Then the next one is under metal. Or sometimes people will call it thermophysics. Anyway, if you cannot find it, let me know. I will send to you again. Then you
Yeah, I
need
got it.
to, okay, field of point mass, you need to know how to get this formula and memorize this formula. Sometimes it's called acceleration due to gravity, but this chapter we are calling it gravitational field strength. Then gravitational potential, you need to know the definition. Work done per unit mass in taking the mass from infinity to the point, and that is the potential at a point, a distance r from the center of the point mass. The negative sign must be there. This one negative sign Doesn't matter, it depends on your choice. Okay, so now we are going to use this formula, all these formulas in solving problem. These two are in the formula sheet. This one no, this one you have to recall and memorize.
The G one,
Ah,
small G.
G, gravitational field strength. Okay, I just show you. I'm not giving you any homework because I think now you should be preparing for your AS. Okay, it's the two formula given. So if you want, if you got question to, anyway, I'll go over with you lah. If you want me to revise with you, let me know. If not, I will assume that you revise yourself lah. Right, motion of satellite. Right, just summarize for you. That's the mass of the satellite. That's the mass of the Earth or mass of the body that the satellite is circulating. And then is the radius of orbit R. Right? This usually worth 1 point lah, if they ask you to derive. Right? The gravitational force provides centripetal force. Centripetal force is the gravitational force. And then this equation cancel the mass of quite popular lah. Get V square over GM over R. Then to get the kinetic energy formula, you replace this V square with this V to get this formula. Then replacing the V 2 pi R over T to get this formula. Right? Essentially, you need to know how to derive lah. Right? They are changing it slightly lah. You'll see in one of the questions. Then we come to geostationary satellite or geostationary orbit. Right? Essentially, the satellite stays above the same point on Earth. One thing good is light telecast. I just send the signal up, and then you send it to the receiving station. No? You don't have to have a tracking, don't have to track where is the satellite, you just put your the antenna direction to the satellite, then that's all. No need to keep on tracking or changing the direction antenna. Condition memorize, rotate from west to east, direction of the Earth's rotation, period of rotation is 4 hours, orbit above the equator. Okay. If you got question to ask, right? This is a short form lah. This is 2020, paper 2020, variant or paper 21, question number 1. Okay. If you got question to ask. Okay, let's try this question. Show that the satellite orbiting this one, we won't show that lah. We just pass through it. We'll try this question lah. A satellite of mass 120 kilogram orbits the Earth at a distance of 660 kilometers at a speed of 10. Calculate the mass of the Earth, kinetic energy, potential energy, and total energy of the satellite. Okay, usually they ask you to derive, they will ask you to use a formula lah. So we just square that to get this formula and put in the value. Velocity, that's a velocity. G, data sheet, that's capital G. M is what we want to find. R is what is given there. Convert it to meter. And we get our equation of M. Okay. Kinetic energy. Use this formula. Don't memorize. Use this formula. EK is half mv squared. replace a v square with that, or just use half 120 770, right? Either way, but since it's easier, I don't need to use the formula lah. I need to replace the v square there. Just use the formula and calculate out. Then potential energy formula, you need to go to the, either you memorize it or you go to the formula sheet. Right? That's a, okay. So put in the formula, calculate out, you get the answer minus 7.26 times 10 to the power 9. Important, the negative sign must be there.
Can I see a 4?
Say again,
Can I see the up there 4?
can't hear, can't hear.
Can I see? Can I see? Hello?
Yeah, yeah. Okay. So you just add the two together to get the total energy, kinetic and potential add together.
Oh, okay.
I will solve for you all of them, right? Total energy is kinetic plus potential, right? So you have got kinetic, got potential, and then complete out, negative sign, right? Total energy and potential energy always negative sign one because of our choice of reference at infinity at zero potential energy. Okay, I'll show you if the satellite is now increased to a orbit of radius 6890 kilometer, calculate the new speed at its orbit. Use this formula again, or right? Don't want to use this, don't want to calculate G and M, we square that, so it's V square over R is a constant. So use proportion, no? V2 square R2 equals to V1 square R1. Right? V2 is what we want to find. Right? That one 68990. This is the previous speed V1 square, and then this one is 6610 that is given previously, and calculate our V2. Okay, I'll let you go and try the others. Okay. Remember, we calculate this question. Question 8, 2 point masses, each of mass 20 kilogram and 90 kilogram are placed 10 meters apart. Find from the smaller mass where the gravitational field strength on the line joining both mass is 0. Right? Remember, it's a vector quantity, so it's up to us to choose which direction we want. Is positive, it should be negative. So since we want the point where the gravitational field strength is 0, we let the distance from the smaller mass be x meter. So the distance from the bigger mass to the point where the field is 0 is 10 minus x. So this is the smaller mass, gravitation for the smallest mass. Okay, we are basically using this formula that you are supposed to memorize. Right? Calculate 20 x squared, and after that calculate G2. Right? G mass 90, 10 minus x squared, that is your distance. Calculate out. Now, the gravitation is 0, G1 equals to G2. Right? So G1 equals to G2. This one will cancel off. This one will cancel off. This 0 and 0 cancel off. This will be 2. This will be 9. Then we cross multiply. We get this equation. Then we square root it. Right? Simplify, square root and simplify. And solve our equation. Okay or not?
Yeah, okay.
Now we are going to calculate potential. Then we draw this graph lah, which is this equation now. Sketch only smaller mass, smaller gravitational field strength at the surface, bigger mass, larger gravitational potential. So the choice of whether it's curving this way or curving the other way is your choice. Right? This one you take it to the left as positive. Okay, let's calculate the potential at the neutral point. Right? The field may be 0, but the potential is not 0. Okay, that's the formula for potential. So we take our G out, R is X, that's the first one. And then minus the second one. Right? That's your G we have taken out. M is 90, R is 10 minus X. Put in our value for G, put in our value for X. Right? We have calculated from there. Okay, that's where we have calculated. For X is 3.2. So if it's 3.2, that one will be 10 minus 3.2 is 6.8. And calculate out. Okay or not? Anything not clear?
Okay.
Okay, let's try some partial paper. This is 2010 November, paper 41, number 9. Define gravitational field strength, force per unit mass. An isolate star has a radius r. The mass of the star may be considered to be at a point mass at the center of the star. The gravitational field strength at the surface of the star is Gs. On figure 1.1, sketch the graph to show the variation of the gravitational field strength of the star with distance from its center. You should consider distance ranging from r to 4r. Right? You can do it. If not, write it down. There's a formula you are required to memorize. And you are given. Right? Radius is r. Surface Gs. Then put in, cross multiply there. Gs over r is Gm. Right? This is a constant. So that can be equal to another gr squared. And calculate for 2r. Right? 2r, if you know straight away, go ahead. No need to go to all the maths. Just calculate out on the paper. Right? A quarter, 19, 116. That's why, right? As I said, value is positive or negative is your choice. So this one, they want to put it positive is okay. Right? At the surface, and a quarter is 2.5, 0.3 is here, 2.5 is about there. And then 19, 116. And draw. Okay.
Okay.
19 and 18 about almost the same place. The Earth and Moon may be considered to be spheres that are isolated in space with their masses concentrated at the center. The mass of the Earth and the Moon, they are given. The radius of the Earth is RE. Radius of the Earth is RE. And the separation from center of the Earth and center of the Moon is 60. Center to center is 60 RE, as illustrated in figure 5.1.2. Explain why there is a point between the Earth and the Moon at which the gravitational field strength is 0. Can you explain? Ken, why is there a point where the gravitational field strength is 0?
Because it's out of orbit.
No? Right? There's a point there. Right? At distance x, then this should be 60 RE minus x. That's the gravitational field strength of the Earth. Right? Using this formula. Mass of the Earth is given. G, we can put it as G. Then this is your x squared. Then gravitational field strength of the Moon is there. Right? Both of them are in different direction. They are vector quantity. So there is a point where the two are equal. So the gravitational field strength is 0. Okay, now?
Okay.
Gravitational field of the Earth and the Moon are in opposite direction. That's the key. The resultant field is found by subtraction of the field strength. So there is a point where it is 0. Determine the distance in terms of RE from the center of the Earth at which the gravitational field strength is 0. Gravitational field strength of the Earth and the Moon are equal. The resultant field is 0. Right? That's where we show the previous slide. Right? Cross multiply. And then just take this down, divide to get the answer there. Then this will be x squared. And taking square root, don't worry about the negative sign. Okay, can
Okay.
this is sketching now. Same thing now. If g to the left is positive, then g to the right is negative. Okay or not?
Okay.
The 0 point is always towards the moon now, the smaller mass one now. This one we let you do yourself. Think we must have completed it. Memory work only this one. One mark. Force of attraction between point masses is proportional to the product of masses and inversely proportional to the square of the separation. Explain why, although the planet and the sun are not point masses, the law also applies to planets orbiting the sun. Why? Yep. Can you remember?
Uh,
Where is Mr. Saw teaching now?
Here also.
Oh, here also. Got me quite fast already. We missed 2 lessons also in the same.
Uh,
Yep, can.
Forgot the answer.
Separation between the planets and the sun is much greater than the diameter of the sun. Okay.
Oh, okay.
This one is not in the syllabus anymore. So you won't bother about that. Let us try this one. A moon is in circular orbit of radius r about planet. The angular speed of the moon in its orbit is omega. The planet and its moon may be considered to be point masses that are isolated in space. Show that r and omega are related by the expression. Explain their working. So what should we do? The first step. Omega related to period. So what should we do?
Wait, let me find the.
Yep. Deriving the formula, r cubed over t squared equals a constant. Just a change to omega, that's all.
Oh,
Right? So gravitational force provides a centripetal force. Then that is your Newton's law. There's a centripetal force. Right? M and N can cancel off. Take r squared over there. This is gm, r cubed, omega squared. G and M are constant. So that's what we get. Okay or not?
yeah, okay.
First part, derivation. It will always won't be the same. They will just try to twist the question around. Then the next part is using the equation. Right? Probos and demos are moon that are in circular orbit about the planet Mars. Right? The data is given. Okay, find the mass of the Mars from the data given. That's the formula that we have derived. Right? We have period. This is the period given. We calculate omega because we want omega. Omega is 2 pi over t. 2 pi 7 hours. Convert it to second. Get 2.25 10 to the power minus 4 radian per second. Then we can use this formula to find our m. G we can get from data sheet. Okay, that's your G. That's your m. R cube. R cube from here. Cube there. Omega square. Omega we have calculated. And from there can calculate our m. Can anything that's not clear?
Oh, okay. Yeah, I get it.
Then we want to calculate the period. This one. So same thing, no? This play with this equation. That's all.
Teacher, why they give two moons?
Say again.
Why did they give two moons?
That one he cannot answer you lah. Planet have moon. Only God knows lah. God is the one who designed that. So the Earth has one
No, I
moon.
mean,
Say again.
why the question provide with two moons?
They have two moon. No? They told you that the
I think
planet
they use
Mars
either.
have two moon. So they want you to calculate the period of the other moon. No? Demos, they give you the period of one moon.
Oh, okay.
There's a reason why they give you the two moon. And then they want you to use this formula to calculate the period of the demos. So we just use this formula. Right? Put in our value. This one we don't have to worry about. The unit is the same. The time is the same. No need to convert. So R1 cube omega we have calculated that square and out 2 cube, omega 2 square, calculate out, we get our omega. Omega and convert to period. Okay, now
Uh,
anything not clear?
all right.
I won't give you any homework lah, because I think you should spend more time revising your AS and do past year paper AS lah. After your
The whole thing, right?
after your AS results, after your AS exam, then I will give you homework lah. Because now I don't think you have the time to go and waste to do all this homework. Not like some colleges where they offer 1 year AS, 1 year A2. Yours is an overlap AS and A2 together. So now you have to concentrate on A2, learning and understanding it. At the same time, you have to revise your AS to sit for your exam somewhere in May. Your trial exam should be coming up soon. Okay, anything not clear?
Yeah.
Okay, let's finish our last part. We got 10 more minutes, that's all. Less than that, 7 more minutes. Right, we got 23.6 hours. The period of rotation of Mars about its axis is 24.6 hours. Deimos is an equatorial orbit, orbiting the same direction as the direction of spin of Mars about its axis. Use your answer to comment on the orbit of Deimos. What is your comment? Yep, Ken?
So it will take one orbit will take 24.6 hours, right?
Basically, you have to comment on this value and this value. Are they the same? Are they different? So what?
Yes, kind of.
Can or not?
No? Did you hear me?
Almost geostationary, no? Not exactly stationary, almost geostationary. Or satellite would take a long time to cross the sky, no? The satellite and Mars do not rotate at geostationary orbit lah, almost only lah. So that's why it will be a long time. It will stay above above the above Mars for a long time lah. Because it's moving a bit slower lah. Both of them are different speed. Okay, or not? Geostationary means both of them must have the same 24.6 hours. So we have calculate for Deimos is 23.6 hours. Then we are given it. The period of rotation of Mars is 24.6. So 23.6 and 24.6 is almost lah, not exactly lah. So it won't follow exactly lah. It will take a long time for it to cross the sky, no? Okay, huh?
Yeah.
Okay, let us make a start. Anytime we will be cut off lah. Make a start with thermophysics. Okay, I call this matter lah, or thermophysics lah. So we are going to temperature today. Won't finish it, but we will do a bit of it. And so under thermophysics or matter will be temperature, ideal gases, thermodynamic. A link between temperature and behavior of gas molecules was introduced in topic 15. In this topic, the concept of temperature is explored in further detail. Right? Temperature in a container. Right? Under ideal gas, we will study the equation of state as a formula. Right? Kinetic theory, we will think of the molecules as particles in a box. Then we'll derive this equation under ideal gas. And after that, we combine these two equations, get this equation, average kinetic energy per molecule. So a temperature rise, right? This thermodynamic temperature is due to an increase in kinetic energy. Right? So there's an increase in kinetic energy of the gas, ideal gas, there's a temperature rise. Okay, so we are going to study temperature, this topic. Page 39, thermal equilibrium, temperature and thermal energy, temperature scale, specific heat capacity, and latent heat. We'll try to cover 14.1 and 14.2 if we can. And this you need to memorize, know how to use it. Author about the textbook, right? This is syllabus. Heat transfer can be by conduction, convection, radiation. Okay, this one, object, warmer object, higher temperature. This cooler object, lower temperature. Thermal energy is transferred from a high region of higher temperature to a region of lower temperature. Right? Both will give out energy because they have a temperature. But the net flow of thermal energy will be from the warmer one to the cooler one. Thermal energy is defined as the net energy which is transferred from a body at higher temperature to one at lower temperature by conduction, convection, and radiation. Memorize. Temperature of hot, right? Where you lose energy, temperature will go down. Temperature of hot object decreases, or temperature of cool object increases. Right? Thermal energy is transferred to the cooler object. Cooler object will gain energy, so temperature will rises. Both of them are at the same temperature, they are solved thermal equilibrium, so they will